Original cat question. First read the question. Question number 1. This is an original cat question. Original cat question. Read the question, sir. The sum of 4 consecutive 2-digit odd numbers. 2-digit odd numbers. It is 2-digit odd numbers, 4 consecutive 2-digit odd numbers. Odd numbers always ends with 1, 3, 5, 7 or 9. First key point. Odd numbers always ends with 1, 3, 5, 7, 9. When divided by 10, there are 4 consecutive 2-digit odd numbers. When divided by 10, it becomes a perfect square. That means sum of the, if a number is divisible by 10, the unit digit should be 0. That means 4 consecutive odd numbers sum unit digit should be 0. Suppose if I take 1 plus 3 plus 5 plus 7, it is 12, 15, 16, it is 6. It is getting divided by 10. Unit digit should be 0. Next, if I take 3, 5, 7, 9, 16, 21, 24, no. Next, if I take 5, 7, 9, 1, 5, 7, 9, 1. 5 plus 7, 12, 12 plus 9, 21, 21 plus 1, 22. No. Next one, 7, 9, 1, 3. 7 plus 9, 16, 16 plus 1, 17, 17 plus 3, 20. That means the numbers, 4 consecutive numbers we should take should end with 7, 9, 1, 3. Question clear. Which of the following can be possibly be one of these 4 numbers? First option 21. If it is 21, the next number will be 23. Next number will be 19. Next number will be 17. 17 plus 19 is 36. 36 plus 44. 36 plus 44 is 80. 80 divided by 10. 8 is becoming a perfect cube, but I want a perfect square. 1 minute. Perfect square. So first one, it is out. 5 anyway, it is not there. Next is 41. If it is 41, next number will be 43 and next number will be 39 and 37. 37 plus 39, which is nothing but 76 plus 84. 76 plus 84 is 160. When divided by 10, I will get 16. 16 is a perfect square. Which of the following can possibly be one of these 4 numbers? One of these 4 numbers possibly it will be 41. What did I do? Step number 1. They are all, the given question is under odd numbers. Odd numbers always ends with 1, 3, 5, 7 or 9. Total 5 odd numbers are there. I need to pick 4 numbers. When I add it, it should be divisible by 10. Any number divided by 10, unit digit should be 0. So I should select 4 consecutive odd numbers. 1 plus 3 plus 5 plus 7, 16. It should be divisible by 10. Unit digit should be 0. 8 plus 7, 15, 24. No. 12, 21, 22, no. 16, 17, 20. 20, it is ending with a 0. Yes. So 7, 9, 1, 3, it is possibility. Then I plugged in the answer option. Then I checked which one on dividing by 10. I'll get a perfect square. Easy question, numerical reasoning based question. Numerical reasoning based question. First one, original cat question. Second question. The number of employees. This is also an original cat question. This is also an original cat question. Let us see the question. The number of employees in an Obelix Menhir company is a prime number. Number of employees, it is a prime number and it is less than 300. So the total number of employees count is a prime number and the prime number is less than 300. The ratio of the number of employees who are graduates and above to that of employees who are not can possibly be. There are 2 kinds of employees. One is employees who are graduates and employees who are above to that of employees who are not. So graduates and non-graduates. The total sum should be equivalent to a prime number which is less than 300. Which of the following can be? Ratio it is there. If it is graduate employees, these non-graduate employees. Let us go one by one. First option, 101 plus 88, which is nothing but 189. 189, sum of the digits is 8 plus 9, 17, 17 plus 1, 18. 18, that means it is divisible by 3. If it is divisible by 3, it cannot be a prime number. Second option, 187. 187, sum of the odd places minus sum of the even places. That means this number is divisible by 11. How can it be a prime number? C, option C. 110 plus is to 111. So total it will be 221. 221 is 13 ones are 13, 91. 13 into 17. If a number is divisible by 13 and 17, how can it be a prime number? These out. D. 85 plus is to 98. Total it is nothing but 13, these is nothing but 183. Sum of the 183. 183, is it a prime number? 183. Let us go ahead with the another number. We are stuck between D and E is 97 is to 84. So graduates and not graduates. 97 plus 84, which is 181. Which is 181. Let us see whether 183, it is a multiple of, is it a prime number or not? How to check whether for a small numbers whether it is a prime number or not? Take square root of 83. 13 square is 169, 14 square is 196. Write all the prime numbers less than 13. 2, 3, 5, 7, 11 and everything. Just check it out. 183. Sum of the digits is 1 plus 8, 9, 9 plus 3, 12. 12 means it is divisible by 3. 183, it is not possible. So the only answer is 97 is to 84. 97 is to 84 is 181. How to check whether a number is a prime number or not? We are not sure whether 187 is a prime number or not. Assume that we do not know how to check whether a number is a prime number or not. Let us see it. In a company, there are two kinds of employees, graduate employees and non-graduate employees. Some should be a prime number less than 300. A, B, C, D, it is out. How to check whether a number is a prime number or not? Please write down. There are many ways to check whether a number is a prime or composite. Out of that, how to check whether a number is prime or composite? Let us do a lot of questions to understand. One preliminary logic is, now see here. The first one, suppose we have to check whether 181 is prime or composite. 181, whether it is prime or composite. Step number 1. Take the square root of the given number, 181. 181 is nearer to which square root? 13 square is 169, 14 square is 196. So nearest square is 13. Write all the prime numbers less than 13. Less than or equivalent to 13 because 181 is greater than 169. 2, 3, 5, 7, 11, 13. Check whether 181 is divisible by any of these numbers. 181 is odd number, not possible. Sum is 1, not possible. It should end with 0 or for 5, no. 7 2s are 14, 41 not possible. 11 not possible, 13 not possible. Therefore, 181 is definitely a prime number. But for the smaller numbers, you can easily cross-check. Suppose if the question is, if it is 973, you have to do square root of 973. Square root of 973 is 31 square is 961. 32 square is 1024. Writing all the prime numbers less than or equivalent to 31 and checking for each and every number, it is an ambiguous process. It is a very time consuming process. And what is the another method to do? How to check whether 973 is prime or composite? Prime or composite. These 973 can be written as 10 cube minus 27. Yes or no? 1000 minus 27 is 973. This is 10 power 3 minus 3 power 3. A power n minus b power n is always divisible by a minus b. as long as n is a natural number. 10 power 3 minus 3 power 3. 10 minus 3, it is nothing but 7. So these 973 is divisible by 7. If it is divisible by 7, answer is nothing but a composite number. Writing all the prime numbers less than root 10 is a very time consuming process. Instead of it, what you can do is check whether the number can be written of the form a power n plus or minus b power n. A power n plus or minus b power n. If you are able to write it as a power n plus or minus b power n, easily you can solve it. Second example over. Third example, let me do one more example. 27 followed by 5 zeros ending with 1, whether it is prime or composite. Square root method to check whether a number is a prime or composite is a very time consuming method. So if the number of digits are more, you can use this logic. These 27 into 10 power 6 plus 1. These nothing but 3 into 10 square whole cube plus 1 whole cube. A power n plus b power n. It is always divisible by a plus b. It is always divisible by a plus b if n is an odd number. 3 into 10 square whole cube plus 1 whole cube. It is divisible by 300 plus 1, 301. 301 is 7 into 43. If it is divisible by 7 and 43, how can it be a prime number? Answer for this question is composite number. Answer for this question is composite number. I hope the idea it is clear, right? You can do a lot of these questions orally because of these logics, sir. Suppose for example, is 391 prime or composite? Is 391 prime or composite? This can be written as 40 square minus 9. These are nothing but 20 square minus 3 square. These are nothing but divisible by a minus b and a plus b. So if it is divisible by 17 and 23, how can it be a composite number? For a 3-digit number, you can use that square root logic. But as the number of digits increases, the complexity of finding whether the number is a prime or composite also will increase. I hope this idea it is clear. Suppose instead of this, the question can also be like this. Is 2 power 2007 plus 1 prime or composite? Is 2 power 2007 plus 1 prime or composite? Same logic. 2 power 2007. 1 can be written as 1 power 2007. A power n plus b power n. A power n plus b power n is always divisible by a plus b if n is an odd number. That means this is always divisible by 3. If it is divisible by 3, it cannot be a prime number. Answer for this question is composite number. Answer for this question is composite number. I hope the idea it is clear, right? I hope the idea it is clear. Suppose for example, if the question is like this, 7 power 12 plus for example 27. 7 power 12 plus 27. We have to check whether this number is a prime number or a composite number. This can be written as 7 power 4 power 3. 27 can be written as 3 cube. A power n plus b power n is always divisible by a plus b if n is an odd number. 3 is an odd number. So it is nothing but it is a composite number. Telling that a number is a composite number is extremely easy than proving that a number is a prime number. So various concepts related to the first question we solved. To check whether a number is a prime number or not, in mathematical world, this is called an undecidable problem. This is called an undecidable problem. What do you mean by an undecidable problem? A problem is said to be undecidable if there are many ways to solve a problem. If there are many ways to solve a problem, or if there is no way to solve a problem, then that problems are called as undecidable problem. A prime number, telling whether a number is a prime number or not, there are close to 237 ways to check whether a number is a prime or composite. Apply method number 1. Right? If it fails, go to method number 2. If it fails, go to method number 3. If it fails, go to method number 3. If all 237 fails, then the number is said to be a prime number. I am repeating it. If all 237 fails, then the number is said to be a prime number. Complexity of proving that a number is a prime number is one of the biggest mathematical challenges. Question number 1 is based on prime numbers. So we discussed how to check whether a number is a prime number or not. For a simpler number we did it, we increased the number of digits, then we did it for a very complex problems. I hope concept related to first question it is clear. This is also an original CAT question. This is also an original CAT question. The integers 1, 2, 3 and so on up to 40. The integers 1, 2, 3, 4 and so on up to 40 are written on a blackboard. The following operation is then repeated 39 times. What is that operation? In each repetition, any two numbers, say A and B, currently on the blackboard are erased and a new number is written. Two numbers are taken, A and B. Both are erased. It is replaced by one number, A plus B minus 1. Suppose with a simple example we will do it. Suppose if it is 1, 2 and 3. What he did, he erased these two numbers, 1 and 2, and he replaced it with another number which is A plus B minus 1. Right? What he did, if numbers are there, 40 numbers are there, he did 39 times. Here 3 numbers are there, he did it 2 times. Again he removed this one. Then again he replaced it with these A, this is B minus 1. That means it is 1 plus 2 plus 3 minus 1 is minus 2. Minus 2. That means this is nothing but if 3 numbers are there, the final result is sum of all the numbers minus the operation performed how many times. Operation is performed how many times? 2 times. Suppose if it is 1, 2, 3, 4. 1 and 2 it is removed. It is replaced by 1 plus 2 minus 1. Again 3 and 4 are removed. It is replaced by 3 plus 4 minus 1. Again these both are removed. 1 plus 2 minus 1 plus 3 plus 4 minus 1 minus 1. This is nothing but 1 plus 2 plus 3 plus 4. Operation is performed 3 times. So it is minus 3 with the sum of all the numbers taken. Simple logic. 40 numbers are there. So total numbers. Operation is performed 39 times. It is minus 39. So these is nothing but 40 into 41 by 2 minus 39. These 820 minus 39, which is nothing but 781. Answer for this question is 781. If two numbers are there, 2 numbers minus 1. If operation is performed once. If 3 numbers are there, sum of the numbers minus 2. If 40 numbers are there, 1 plus 2 and so on up to 40. Operation is performed 39 times. So it is minus 39. There are 2 examples which I did it so that you will understand how directly you can get this answer. This is a CAT question. This is a CAT question. This is also a CAT question. So totally all these questions are CAT questions. Next one. What are the last 2 digits for 7 power 2008? You can solve this problem in multiple ways. Method number 1. Method number 1. 7 power 2008. First make it into 7 square power 1004. 7 square power 1004. Next it is 7 square is nothing but 49. 49 power 1004. 49 power 1004. Last 2 digits of any number. Last 2 digits of a number. Last 2 digits of a number. It is nothing but the remainder when you divide a number by 100. Last 2 digits of a number. It is nothing but the remainder when you do a It is nothing but the remainder when you do a number remainder by 100. 49 power 1004. Last 2 digits is nothing but divided by 100. 49 power 1004 divided by 100. 100 ones are 100. It is minus 51. Minus 51 power 1004. So it is 51 power 1004. 1 power any number 1. 5 4s are 20. 0 1. Answer for this question is 0 1. I hope the idea it is clear. Method 1, wherever, always remember, there is only shortcut where the unit digit is 1. 9 square, it can give you 1. 9, move it to 1. If it is 3 or 7, 3 square is 9, 7 square is 49. 3 or 7, move it to 9, automatically it will move it to 1. 1, 9, 1, 3 or 9, 7 or 9. Once you get an odd number, then the logic is very, very easy. 7 square power 1004. 7 square is 49. Last two digits of any number is the remainder when you divide a number by 100. 49 divided by 100 minus 51 power 1004. Answer is 0 1. This is one way. In case if you know the logic of finding the last two digits using 1 as the unit digit, go with this logic. In case if you want to go by the pattern, method 2. In case if you want to go by the cyclicity or the pattern behavior, that also is a right method. 7 power 1 is 7, 0 7. 7 square is 49. 7 cube is 7 square into 7, 49 into 7, 343. 7 power 4 is 43 into 7, it is 0 1. 7 power 5, it is 7 power 1 into 7 power 4. 1 into 0 7, 0 7. 7 power 6 is 7 square into 7 power 4. 7 power 4 is 0 1 into 49. It is 49. 7 power 7 is 7 power 4 into 7 cube. Anyway, 7 power 4 is 0 1. Again, it is 43. 7 power 8 is 7 power 4 whole square, which is 0 1. That means if the power is a multiple of 4, what is the answer that we are getting? 0 1. Answer for this question is 0 1. Why? Because 7 power 4k. 7 power 4k, last two digits is nothing but 0 1. 7 power 4k, last two digits is nothing but 0 1. Idea clear, right? Either you can go by the cyclicity approach. The cyclicity of 7 in this case is 4 steps. After 4 steps, again the value is coming. 7 power 4, 0 1, 7 power 8, 0 1, 7 power 12, 0 1, 0 1, 0 1, 0 1. These the cyclicity logic, method number 1. If you are comfortable in using that 1 as the unit digit logic, go ahead with this. Use any logic that you think is comfortable for you. Idea is to get the answer fast. Next one. Another. This is also an original CAT question. Most of the questions that we are discussing today in this session are original CAT questions. Suppose the seed of any integer. Seed is nothing but, here the definition is there. Seed is nothing but the sum of the digits of a number. Single digit, that is the same number. Otherwise 6 plus 8, 14, which is 5. How many positive integers such that n is less than 500? Okay, natural number should be less than 500. Seed of n is 9. What is the lowest number where the digital sum will be 9? It is 9. If I add 9 to it, it is nothing but 18. Seed of 18 is 1 plus 8, 9. Seed of 27, 2 plus 7, 9. 36, 3 plus 6, 9. 45, 4 plus 5, 9. So answer is 9k, it should be less than 500. 9k, it should be less than 500. All the multiples of 9 will have digital sum 9. So what will be the logic? K equivalent to 1. 9 5s are 45, 50, 55 point something. From 1 to 55. Total how many numbers are there? 55 numbers will have digital sum as a 9. Sir, what if it is not a digital sum 9? What if it is some other number? That also we will see it. I hope the idea is clear. The lowest single digit number with a digital sum 9, it is 9. Every time if you add 9 to it, the digital sum will not change. If the digital sum is x plus 9k, digital sum will not change. X plus 9k, digital sum will not change. Suppose if the question is, let us see, seed of n is not 9. If the question is Seed of n is 5. Seed of n is 5. What you have to do is, the lowest number whose digital sum is 5, it is 5. Every time if you add 9, the digital sum will not change. 5 plus 9k is the form. K is 1, so it is 14. K is 2, it is nothing but 23. 2 plus 3, it is 5. K is 3, 27 plus 5, 32. So the logic will be, lowest it is 5, next it is 14, 23, 32 and so on. So the form of the number is 5 plus 9k, 5 plus 9k, and it should be less than 500. 9k is less than 495. So k is less than 9 5s are 45, it is 59. So k will be from 1 to, k is less than 59. K is starting from 0, sir. 0 to 58. 0 to 58, because if I substitute 0, I will get 5 plus 9 into 0. Lowest number I will get. He has not mentioned that numbers should be at 2 digits or anything. So k will be from 0 to 58. K is less than 58. So 0 to 58. Totally, how many positive integers will be there, such that the seed of that positive integer, it is 5. Lowest number with the digital sum 5 is 5. If I add 9 to it, digital sum will not change. Two important key points, please make a note of it. Please make a note of it. This question will give an idea to our another question. Adding 9k to any number, digital is equivalent to, adding any number is equivalent to digital sum of the given number. Please write down this point. If you add 9k to any number, whatever the digital sum that will be there for the number, answer also the digital sum will remain same. 23 plus 18, it is nothing but 41. This is 5, this is 5. Digital sum is same. 37 plus 27, it is 64. This is 1, this is 1. Digital sum, it is the same. Adding 9k to any number, digital sum of the given final answer will be equivalent to the digital sum of the given number. Next point, x into 9k, answer digital sum will be 9. Please write down. You multiply any number by 9k. You multiply any number by 9k. Multiply any number by 9k. Multiply any number by 9k. Answer digital sum is always 9. Multiply any number by 9k. Answer digital sum will always be 9. Two important key points. These two key points, make a note. We did a question based on adding 9k to any number. Now we will do a question based on multiplying any number by 9k. These also are management exam replica question. We will not solve problems. We will solve all the variety of concepts that can come because of this problem. There is a 6-digit number. Leftmost, it is 1. That number is multiplied by 3. I will get another 6-digit number, A, B, C, D, E, 1. Leftmost one became a rightmost one. Remaining 5 digits did not change. If I call these number as S, these number as P, these number as P. There is a 6-digit number with the leftmost one. If that number is multiplied by 3, I got another 6-digit number. Leftmost one became the rightmost one. Question is, find the digital sum of S. Find the digital sum of S. Options are 3, 5, 7, 9. 3, 5, 7, 9. Very good question. What people will do is, they will try to find out the values of A, B, C, D and E. You don't need to find the values of A, B, C, D and E. Please see what is the digital sum of S. Digital sum is nothing but the sum of the digits, which is 1 plus A plus B plus C plus D plus E. What is the digital sum of P? Digital sum of P is nothing but sum of the digits. A plus B plus C plus D plus E plus 1. Can I say these both are same? Yes or no? 2 plus 1 plus 3 is also same as 2 plus 3 plus 1, right? So the digital sum of this number is equivalent to digital sum of this number. Suppose if I keep 3. 3 into 3, it is 9. Both should be same. It is not possible. If it is 5, 5 3s are 15. 15 digital sum is 6. 5 and 6, it is not possible. If it is 7, 7 3s are 21. 21, 2 plus 1, 3. Digital sum of the question should be equivalent to digital sum of the answer. Next it is 9. 9 3s are 27. What is 2 plus 7? 9. Answer is 9. Beautiful problem. If you analyze it, this question is a 10 seconds question. Otherwise, you have to decode the values of A, B, C, D. A, B, C, D. I hope the idea it is very, very clear to each one of you. Again, I am telling you the two learnings from these seed question. The first thing is x plus 9k, the digital sum of x will not change. You multiply any number by 9, answer digital sum will be 9. 1 A, B, C, D, E. Sum of the digits is 1 plus A plus B plus C plus D plus E. Answer also it is A plus B plus C plus D plus E plus 1. Digital sum in the question is equivalent to digital sum in the answer. Play around with the answer options. I hope the idea it is clear.